Well, hello, eighth graders. We are starting our statistics strand, the last one for this school year. So statistics, you definitely learned some in seventh grade. I don't know if any of this sounds familiar to you, box plots and dot plots and comparing two sets of data and the 5-number summary and the mean, median, and the mode. And you did a lot of stuff with statistics, but everything you did in seventh grade was what we call univariate data. The prefix uni means one, like unicycle has one wheel. So you only had one set of data for one variable. This year, we have to extend our knowledge to more data for more variables. And to help us get into that, I actually asked you guys to fill out a Google form. A bunch of you did. And let's start by giving ourselves some definitions. And then we're going to look at that data that you guys gave me and do some stuff with it. So you guys need to get out page 108. And on the top of page 108, you need to write some of the stuff down. We are starting with creating something called a two-way table. We're going to make 4 of them, actually, if you look down on your paper, and we're going to create these out of your data that I gathered from you in the Google form. So it says, what is a two-way table? It is a way to organize and display bivariate. Remember, I just said in 7th grade, you did a lot of univariate data. This year, you're going to do bivariate data. Univariate, unicycle, one wheel, bicycle, 2 wheels. Anyway, bivariate categorical data. And then one clarification right away over here, you're like, okay, that's great, but what does this stuff mean? Well, bivariate means data for 2 variables. Instead of just looking at one, saying, I want to know what shoe size you all have, and I make a big list, that's just one variable, shoe size. This year, we're going to take 2 variables, data for 2 variables, and we're going to make some comparisons. That's what bivariate data does for you. You look at 2 variables and you say, do they go together at all? Do they have any connections? So two-way table is a way to organize and display bivariate, 2 variables, categorical data. What's categorical? Well, every question I asked you in the Google form was categorical because the answers that you gave me were not in numbers, they were in groups. And it's easier to see the difference as we start looking at more. So to clarify what all this means, let's start filling in some tables and give ourselves some vocabulary for all of this. One of the questions that I asked you in your Google form is I just asked, are you right or left-handed? So when I asked you that, are you left-handed or right-handed? That's categorical, 2 categories, right-handed or left-handed, and you guys just picked one. So that's categorical data. So I'm going to put on this chart right here, in this box over here, we're going to fill in this two-way table number 1. It's called a two-way table. I'm going to put right-handed in this box and left-handed in this box. Now, when I asked you guys, are you right-handed or left-handed? That was just 2 categories and you all picked one or the other. I'm going to come all the way over. So you'll hear me talk about rows versus columns a lot in this video. I'm going to come all the way over to the end of this row and I'm going to tell you this number. And I'm going to come all the way to the end of this row and I'm going to tell you this number. What do those 2 numbers mean? Well, they are the totals that go along. A row goes along with the entire row. So your headings over here and your totals over here. This means that 104 of you were right-handed and 6 of you were left-handed. Okay, that's what that means. That is one variable, right-handed or left-handed. That is one variable's worth of data. Okay, I also gathered more information from you, and I'm going to put the other variable in this other column. Okay, so I'm going to use these columns to get another variable. Another question I asked you is, do you play an instrument? And again, that was categorical because you just picked one of 2 categories. You picked yes or no, categorical data. So I'm going to put in this column, yes. And I'm going to put this to remember yes to what? Yes, do you play an instrument? Or no. Some of you said, yes, I play an instrument. And I didn't specify which. I just said, do you play an instrument? And you either said yes or no. Once again, I'm going to come all the way down to the bottom of this column here. And I'm going to tell you the totals of that question. 67 of you said, yes, you play an instrument. And 43 of you said, no, you don't. Okay. What about this corner over here? Well, first of all, I'm going to tell you this. All right. I'm going to highlight some things and I'm going to give you some important information here. I've been using all these shades of blue. So I'm going to use this dark blue here to trace all the way around the outer column and the outer row, the ones that say totals on them. Okay. Those have a name in a two-way table. All of these on the outside edge, and I haven't forgotten about this last box. I'll get to it in a second, but I'm going to turn my paper sideways and I'm going to tell myself that these are called marginal frequencies. Because, you know, as if saying bivariate categorical data, we don't have enough new vocabulary yet. Let's add some more. Marginal frequencies, they're called that. A frequency is just a count. And I didn't have to actually go through and count them. Google Forms did it for me. But that's what happened is I asked you a question. I said, are you left-handed or right-handed? And we got a frequency. 104 is the frequency of right-handed and 6 is the frequency of left-handed. Then I also asked you, do you play an instrument? And again, we got a frequency, yes or no. Those are frequencies. Now, this last corner down here is part of the marginal. Why do you think they're called marginal frequencies? Well, have you ever like adjusted the margins on a paper? Margins are the outside edge. That's where these are. They're in the margins. So they call them marginal frequencies. Now watch what happens if I add up. Well, 104 plus 6, I don't really need a calculator for this, but 104 plus 6 is 110. And watch what happens if I add up these totals as well. 67 plus 43 is also 110. It's really important that those totals come out the same. Otherwise, I did something wrong in my frequencies. That means overall, 110 eighth graders noticed that message in their Canvas inbox and responded to the Google form. That's not every eighth grader. That's just how many filled it out. Okay, so those two should add up to the same. This whole area is called marginal frequencies. Now, that's interesting. That's fine. That tells us some stuff. But really, what's the point of looking at two variables of data if you're not going to compare them at all? So these marginal frequencies only tell us one thing about that group. These marginal frequencies tell me who plays an instrument or not. That's one variable. These marginal frequencies tell me who's right-handed or left-handed. That's one variable. We get to the bivariate stuff as we fill in here. And this, I'm going to tell you, was a little bit more complicated for me to calculate because then I had to go through and I had to find. This box is going to tell me, and I'm going to use this pinkish color here. This box is going to tell me how many of you were two variables of things. How many of you are left-handed and play an instrument? This is the area where we start to get to the bivariate. Now I'm actually looking at two variables worth of stuff. So this right-handed, actually I'm going to use this darker notes, then it'll stand out. You'll see what I mean. So let me give you the data in here. Okay. I actually went through all the left-handed responses because there were only 6. And I found that 4 of the left-handed people do play an instrument and 2 of them do not. Okay. Now what that allowed me to do was use some subtraction to figure out the rest, but now I'm going to tell you these numbers as well. 63 of you right-handed people play an instrument and 41 of you right-handed people do not. Now, here's what's really, really important. Again, to double check here, all of the rows should add up and all of the columns should add up. 63 plus 41 gives me that total frequency of right-handed people. 4 plus 2 is 6. The columns should also add up. 63 plus 4 is 67 and 41 plus 2 is 43. But these in here are a little bit more interesting to us because they actually tell us bivariate information. The marginal frequencies are still only telling us one variable. Who plays an instrument and what hand do you write with? That's separate, one variable. So the marginal frequencies are still one variable. I'm going to turn my paper sideways again, and you can fit this in wherever you have room. These inner ones that I just traced with this like peach color, they are called joint frequencies because they are now giving me 2 pieces of information. Marginal frequencies are on the outside. It's really just one variable. Joint frequencies are on the inside. It's 2 variables. Okay. So these boxes tell me 2 things about you. This means that there are only 2 people that are left-handed and do not play an instrument, bivariate, both variables there. There are 41 people that are right-handed and don't play an instrument. Marginal frequencies, joint frequencies. Now, sometimes what you have to do is sometimes you are given some of the table and you have to find the rest. Like let's say on this one I started by giving you marginal frequencies. What if I change this up a little bit? So in number 2, let's compare something different. Instead of right-handed and left-handed, I also asked you this. Do you like camping? And you said yes or no. That's categorical data, because I just said, do you like to camp? And you said yes or no. And then also I asked you, let's go back to the instruments. You can combine different variables and find some interesting comparisons. Okay, but what I'm actually going to give you this time, I'm actually going to start you with the joint frequencies. I'm going to tell you what I found there. I found that 53 of you said yes to both. This box right here means you like camping and you play an instrument. This box right here is who said no to both. 6 of you said no to both of those. No, I don't like camping, and no, I also do not play an instrument. 37 of you said, yes, I like camping, but no, I don't play an instrument. And 14 of you said, no, I don't like camping, but yes, I do play an instrument. If I start you with the joint frequencies, can you find the marginal ones? You should be able to by simply adding. Add across. If I add across these rows, 53 plus 37, 90 is my total that like camping. Go across the row to get your total over here. 90 of you total said, yes, I like camping. 14 plus 6 is 20. 20 of you said, no, I don't like camping. These should add up in the rows. Likewise, these should add up in the columns. 53 plus 14, 67 of you in this column. That means 67 is the total that said, yes, I play an instrument. 37 plus 6 is 43. That's the same totals as over here, which it should be because these are just marginal frequencies. These outside marginal frequencies are still just one variable. So now I know yes instrument, no instrument, but I also know yes camping, no camping. Well, guess what 90 plus 20 is? 110, which it should be for all of these because it's the same Google form, the same 110 if you answered every question. Okay, sometimes you'll be given marginal frequencies and asked to find the joint ones. Sometimes you'll be given joint frequencies and asked to find the marginal ones. But once again, these only tell you one thing about the data: who likes camping or who plays an instrument. The joint frequencies inside tell you 2 things about the data: who likes camping and plays an instrument, or doesn't like camping and doesn't like an instrument, or does like camping but doesn't play an instrument, or doesn't like camping, you know, all those things. Now, I asked you some other things in that Google form. So what I'm going to do right now is I'm going to put in the tables in 3 and 4. I'm going to give you some different headings, and I'm going to give you part of the tables. What do I mean by that? Let me show you. Okay, here's some other stuff I asked you. By all means, pause and fill this in. I asked you right-handed, left-handed. We've already talked about that. And I asked you what color your eyes are. And I put it in the categorical data in 4 main categories. Blue, brown, and hazel are the 3 most common in the world. And the other would include stuff like amber eyes. There's a very small group of people that have purple eyes and a lot of people that have gray eyes. And then I also asked you, so we're going to compare right and left-handed to what color your eyes are. And then I also asked you, do you like camping? We talked about that. And I asked you what season is your favorite, winter, summer, spring, or fall. Now, what I'm going to do in these tables 3 and 4 is I'm going to give you just kind of a smattering of numbers. I'm not going to give you all joint frequencies and I'm not going to give you all marginal, but I do want you to do this first. Take a color and just remind yourself, I'm going to use this peachy color here. This region here, because this is more categories than what we had on the other tables. But still, I want you to be aware that this right here is where the bivariate data is going to come into play. This is called joint frequencies. You can even write it again right here. This part is the joint frequency. These are the marginal frequencies. So this stuff will only tell us one variable, while this stuff will tell us two things about that data. If you're in this box, you are right-handed and have blue eyes. Likewise here, all this stuff, you can trace this again. All this stuff here is considered joint frequencies. That's where the bivariate data comes into play. The edges of the table, the marginal frequencies are still just single, one variable. Okay? These inside boxes are really where the stuff gets most interesting. So what I'm going to do right now is I'm going to give you a selection of data. Okay? There's some we already know, but that's okay. Like we already know 104 total of you are right-handed. We already know 110 answered this survey. I'm going to tell you some other stuff now that you didn't already know. Like I'm going to tell you some marginal frequencies down here. 43 of you have blue eyes, 29 of you have brown eyes, and 21 of you have hazel eyes. I'm going to leave the rest of the marginal frequencies for you to try and figure out. I'm going to tell you, you would be able to get those, but then you wouldn't be able to get any of the joint frequencies unless I give you some. So I'm going to give you some right now. Ready? This is kind of interesting. You ready? You ready? Only one person is left-handed with brown eyes. Only one person in our survey was left-handed with hazel eyes, and only one person was left-handed with other eyes. Your job right now is to pause this video and see if you can fill in the rest of this table with the information that I just gave you. Can you get the rest? Pause me and give it a try. Okay, let's see how you did and where these all come from. So first of all, I can get the rest of these. This one I already knew, but even if I didn't, I would simply go 110 minus 104. If I already know some totals, then I can use subtraction to get the other pieces. So I know 6 people have to be left-handed because every single column has to add up and every single row has to add up. So if I already know 110, if I know 43 blue, 29 brown, 21 hazel, I can subtract all of those values from 110, and there are 17 of you left to have other eyes. That could be gray, that could be green, that could be purple, that could be ambrose. Amber. Okay, so I have all the marginal frequencies now. Can I do a similar thing with the columns in order to figure out the joint frequencies? Well, I can for these 3 columns. If I have a total of 29 with brown eyes and one person is left-handed, well, then it's a simple matter of 29 minus 1, 28. Oh, I better use the right colors here. 28 of you have brown eyes and are right-handed. 20 of you have hazel eyes and are right-handed. And 16 of you have other color eyes and are right-handed. Can I use this column to figure out the joint for blue? No, because I don't have any more information. So I have to go back to the rows. 104 minus 16 minus 20 minus 28 leaves 40 of you to have blue eyes and be right-handed. 6 minus these 3 leaves 3 of you that are left-handed and have blue eyes. So you can use addition and subtraction throughout the table to, even if you only have parts of it, you can figure out the rest. And you're going to try this one more time. Let's compare. Let's find out if there's any kind of connection between do you like camping and what season is your favorite. So I'm going to give you a couple a couple marginal. These are marginal frequencies. We know these ones. 20 of you do not like camping, 110 of you total. Here's some other marginal frequencies you don't know yet. 13 of you said winter is your favorite, and 32 of you said spring. Now I'm also going to give you some joint frequencies. 5 of you said winter is your favorite and you do not like camping. 5 of you said both of those things. 35 of you said summer is your favorite and you do like camping, and 5 of you said summer is your favorite and you don't like camping. I'm also going to give you one more number. 20 of you. This is a joint frequency, so it tells you this is how many people said, yes, I like camping and fall is my favorite. Once again, pause the video and finish this table. Go ahead. Ta-da! How'd you do? Were you able to get all of those values? Now, today is really just about understanding what a two-way table is. We're going to get into a lot more detailed information about what this two-way table even tells us about this data. For the rest of this page here, you just need to write down one observation from each table, one thing that you noticed as you were making the table, as we were talking about the table. So for table number 1, you should be talking to me about right-handed, left-handed versus instruments you play. And it really is more interesting. Don't tell me things like more people are right-handed. Well, yeah, that's true in the whole world. It is more interesting if you come up with an observation related to the joint frequencies. So I'm going to help you with this first one. For example, I noticed, first of all, that more right-handed people play an instrument than don't, but that's also true for left-handed people. So I notice in here that there's kind of an even ratio here of how many people play an instrument versus not, and it kind of doesn't matter whether you're left-handed or right-handed. So I might write something like that. There is an equal ratio in right and left hand for playing instruments. Now, right now, it's not super specific because we're going to learn how to do that tomorrow, but you're going to go through the other tables and tell me if anything jumps out at you. Is there anything that you notice from the table? Like for me on number 4, right away, I noticed that, hey, people that don't like camping don't necessarily love a specific season. They're all spread out. But if I start looking at a certain column, like this summer column, people who love summer do tend to love camping more. So maybe there's something to that. So you're going to write, what I need you to do now is finish writing down one observation from each of those 3 tables left, and then submit a photo of this page.